Hello, I'm Joseph Kibbe, and I'm going to talk today a little bit about the market for hybrid cars. And to kind of put this in context, we sort of need to step back in time a little bit when I was actually putting this project together. And that would be the year 2007. And at the time, oil prices were at record highs. Granted, it was only $66.52 a barrel, which kind of pales compared to what happened last summer, but at the time it was pretty high. And so the solution that many people had to this problem was to buy one of these, a hybrid car. And something interesting happened. They couldn't make enough of them. This is from the New York Times on the 17th of April. Toyota had to increase imports to meet the demand. They actually had to divert cars from the Japanese market so that they could sell them in America. And so, we can kind of look at what might have happened. US hybrid sales, and this is kind of a projection just sort of using an exponential regression of how the market might have moved. And so, sort of with this reference behavior in mind, we can sort of begin to understand the problem. And to do that, of course, we would build a model. And this is the finished model, and I'll just take you through sort of the three main parts of this model that I have sort of dissected here. So if we look at this, I mean, really this is just a classic microeconomic model. On the left side, we have supply and how the supply chain supplies the market. And then on the right side here, we have demand. How does the demand work in the market? And then finally, sort of at the top, we've got the market itself, which sort of coordinates how those two pieces interact. And so we can see that the demand interacts with the market and the supply interacts with the market. And that, at the most fundamental level, is how the model works. We can go in maybe a little bit closer and kind of look at how this works. This is the sort of main, the main part of the model here. And you can see that it's a third order material delay, and we start with actual production, and then we supply the market, and then the orders are fulfilled, and then the cars eventually become obsolete. And so then, we go back and we can look at the supply side of the model. And here we see that we are constructing capital. We've got constructed capital. The factories go online, become production capacity, and then at some point they might close because there's too much capacity. And then if we step back and look at the demand side of the model, there are really sort of three parts of this too. There's sort of the main demand part where new demand is fed in and old demand or demand that is met is fed out. And then down here we have sort of the effect that the price of oil would have on demand. Obviously more expensive oil means more demand. And finally down here we have sort of the perception of availability on how much people want this, because no one wants to have to wait 12 months to get a new car if they need it today. And so now I figured we could just look at one of the many feedback loops in this model, and sort of the prototypical economic relationship is how does price interact with demand, or perhaps how supply interacts with demand. And so here's just one of the feedback loops that we could look at, how the demand backlog affects it, so how the shortage affects the price of these cars. And so the demand backlog feeds into the perceived backlog, which feeds into the effect of the perceived backlog on demand, and that in turn feeds back around and influences how much new demand is there, so that if there's a whole lot of pent-up demand, people will exit the market and buy a different kind of car because they know it's going to take so long to get theirs. So now that we've sort of seen how that loop looks in sort of a more abstract sense, I thought I would just sort of step through the model and focus in on where we're looking in the model and just sort of go through the different components and how they interact. So you can see, just as in our loop, we start off with the demand backlog. How much of a pent-up demand is there for these cars? And then that moves down here into the perceived backlog, because the actual backlog, of course, dictates how the perceived backlog is going to work. And so then that, in turn, is going to feed into the effect of the backlog on the price, of course, which, of course, feeds into the price of the hybrid. And as anyone who's ever studied economics knows, prices send signals in the market. And so this moves up into affect demand, the effect of price on demand, which of course comes back up here, influences new demand itself, and then that feeds back into the demand backlog. And so we can see how this loop is really counteracting, it's self-stabilizing, so that if there's a ton of pent-up demand, then prices through the market will send a signal for people to buy fewer of these cars. And so the market kind of stabilizes itself out. And so now that we've sort of got a sense of how the model works, well, now what? What do we do with this thing? And one of the things we could look at is global warming. It's obviously a problem. And carbon dioxide emissions play a key role in this problem. And of course, cars produce a lot of CO2. So one of the questions you might ask is, well, how could we encourage people to drive hybrid cars? And if we look at this model, we can zoom in on just one of the many areas we could look at, is right down here, where we have the effective price on demand and the effective perceived backlog on demand. And these two things in this model are going to be the demand side elasticity of the consumers in this model, meaning as the price changes, how are these people going to react in sort of a dimensionless way, not related to dollars and cents, just in terms of percentages. And so, I ran some different settings on the model, and we have our reference run, and that gets us up to about there after 60 quarters of sales. That's the time unit I've been using. And so what would happen if we made the demand a little bit more inelastic, meaning that people would react as the price changes even less. Their demand would change less as the price changes. Well, it gets us up to here. And if we make the demand even more elastic, it gets us up to here. And for simplicity's sake, we could just look at a table. You see that just by making the demand a little bit more inelastic, we can get a lot more people to buy these cars. And so, in terms of actual implementation, how would the government do this? There are 4 things that really influence elasticity in the market. The availability of substitutes. How many other different kinds of cars could these people buy? The second is the stability of the price. The consumers think that it's going to be free one day and then $50,000 the next day. Next, we have percentage of income. How much of this item, how much of a person's income does this item take up? And then last is necessity. How much do people need these things? And in this case, we can actually get rid of a number of these things. The stability of price, it stays pretty stable. Percentage of income, cars are always going to be pretty expensive relative to most people's income. And I think it'd be safe to say that most people consider a car a necessity. And so we really focused in here on substitutes. And what could the government do to get rid of substitutes? It could do things like take SUVs off the road, put higher prices on SUVs so that, for example, they really aren't substitutes because they're just so much more expensive. Or give other kinds of incentives in the market to get rid of substitutes by passing laws banning certain types of vehicles or encouraging the production of these hybrid vehicles. And so that's it. That's how we have taken sort of real-world data, built a model, and seen how we can apply that model in the real world to affect real policy changes. Thanks.